circuit shown below is closed for a long time before it is opened at t is equals to 0. This is the switch at t is equals to 0. Then continuing, we've been told to find IL, where IL is at this particular point, then I naught, this particular point, then IV naught at this particular point, where it's the current is flowing through the 20 ohm resistor. Then V naught also it's at 20 ohm resistor. So then the last question is a percentage of the total energy stored in the 4 Henry inductor that is dissipated in 10 ohm resistor. So the final question is a percentage of total energy stored in the 4 ohm inductor that is dissipated in 10 ohm resistor. So we'll start by finding the R equivalent, and R equivalent will be only using the resistance of 2 ohm, 10 ohm and 20 ohm, because at this particular point this circuit will be acting as a short circuit. Hence the relevance of 0.1 ohms will be not significant. Will not be significant as a plea of linguist. Then continuing, so we want to find R equivalent, whereby R equivalent will be 2 plus 20 times 10 all over 20 plus 10. Sorry for that. R equivalent will be 8.667 ohms. Then finding IL is equals to, using the formula of IL is equals to I naught, where I naught is the initial current of 10 amperes, exponential negative R over LT. So coming to this point, after using this particular question,
we'll be having IL is equals to 10 into exponential negative 8.667, which is the resistance, all over 4, which is the inductance. Inductor given as 4 Henrys, times time, which is equals to 10 exponential negative 2.1667 t, or you can leave yours as a fraction, whereby it is 10 exponential negative 13 all over 6 t. So that's the final question for IL. Then next question, we've been told to find I naught with respect to t as t is greater or equals to 0 positive. That's immediately when the switch is opened. So at this particular point, we'll be remaining with a circuit of this particular manner, whereby
we'll be having an inductance there, then a 2 ohm resistor, then at this particular point that's at 20, then 10, so these are 2 ohm resistor, then this is at 10 ohms, this is at 20 ohms. Then we are having the flow of current I naught is at this particular point. Then another one, we are having 4 Henrys at that particular point. Then this V naught at that particular point, where we have 20 ohm resistor. So we have to find I naught, and I using the current division rule, which states that the current in any of the parallel branches, so at this particular point we'll be determining the current flowing through the 20 ohm resistor. So the current in any of the parallel branches of a parallel circuit is equal to the ratio of the opposite branch. At this particular point, opposite branch is 10 ohms resistor. So opposite branch resistance to the sum of all resistance multiplied by the total current. So sum of the total resistance will be 10 plus 20. So in order to find I naught with respect to t, will be IL multiplied by the opposite branch will be 10 over summation of 10 plus 20, that's 30, and that one will be 10 exponential negative 2.1 667 t multiplied by 10 over 30. At that particular point we'll be having I naught respect to t as 3.333 exponential negative 13 all over 6 t amperes. So this one will be the equation or the totality of I naught at 20 ohm resistance. Then finding V naught, because we've been told also to find V naught at 20 ohm resistor. In order to find V naught, we will be having V naught is equals to I naught R, whereby V naught with respect to T is equals to 3.333 exponential negative 13 all over 6 T multiplied by 20, whereby V naught with respect to T is equals to 66.6667 exponential negative 13 all over 6t in volts. So this is the value of V naught with respect to T at the 20 ohm resistance. Then coming back to the last question, whereby we've been told to find the percentage of total energy stored in the 4 Henry, that's the inductor of 4 Henry inductor that is dissipated in 10 ohm resistor. So at that particular point, we'll be having, for energy to be dissipated in the 10 ohm resistance, then at that particular point we'll first of all find the total energy, whereby total energy at this particular point is total energy is equals to a half Li squared. So this is the formula for finding the total energy. Then again, the percentage of energy at 10 ohm, so W at 10 ohm resistor. So in order to find the energy dissipated at 10 ohm resistance, we will differentiate. Let me say we will differentiate that time with VI with respect to time, whereby differentiating that we will be having let me say I squared R. It will be I squared R or V squared all over R with respect to time. So just a minute. So as I earlier said that we can find the energy at 10 ohms by I squared R or V squared R, because we must use R in order to find the accuracy. We must be precise enough by using 10 ohm resistor. So we will use this. So let's say that W at 10 ohms is equals to V squared, and the value of V was 66.667 exponential negative 13 all over 6 t. Then continuing, V squared will be that one will be V squared, that's 66.667 10, then this exponential negative 26 all over 6 t. So in order to find work, this power, this is the value of power right now, so we must integrate it, because these ones are the value of power, and as we know that power is equals to V squared all over R, and work is equals to power, the integral of power. So continuing, in integrating this, it will be, so that's this is the value divided by 10, then that's multiplied by 6, so times 6, then divided by 26, as we know that energy cannot be negative at this particular point. So W at 10 ohms is equals to 102.56 or 57, but I prefer 56 joules. Then finding this, total energy W is equals to W total, that's a half, times 4 times I, whereby the initial current was 10 amperes. So if the initial current was 10 amperes, then I squared will be 100, whereby this one total will be 200 joules. So at this particular point, this is 100%. So we want to find out what percentage is this. So the percentage of energy dissipated at 10 ohm resistor will be 102.56 over 200 times 100%, which is equals to 51.2%. So this is it, and we've now come to the final end